Okay, let me say a little bit about exercise 12.1.10. Here it says to create the Cayley table for the factor group Z8 mod 0246. Okay, so let me just write this 0246. Let me write that as H. Okay, now H is a subgroup of Z8. Now remember, Z8 is additive group, so I can write this as Z8 plus. Now, Z8 consists of the numbers from 0 to 7. Now, you can think of Z8 as having even and odd elements. And the even elements are definitely closed under addition, and they're also closed under inverse. For instance, 2 is the inverse of 6 because 2 plus 6 equals 8, and 8 in Z8 gives you 0. Now, you could make the Cayley table of this, and you could see that it's a subgroup, but just that simple argument I hope can convince you. So it's easier to write H this way rather than writing it out this way. Now, if I want the factor group is the group of cosets. All right. Now, how do you form cosets of H in Z8? Well, you've got Z8 here. Let's just do this in general. If I have a group G here, and I have a subgroup H here, so I'll just say this is additive cosets in general. Right. If I have H here, then whenever I take an element little g in big G, then this little g is in a coset of H. Now, how do you form a coset? That was my question before. This coset would be G plus H. In other words, take the element G plus every element in big H. Now, if I take another element G prime that's not in H or G plus H, then that would be in another coset G prime plus H, etc. All right. So how does this apply in this case? Here I have H. Okay, and let's take an element in Z8 that's not in H. So I can say 1 is in Z8, but not in H. All right, so that means that 1 plus H is a coset. Now, what's 1 plus H? Remember what this means. This means take 1 plus every element of H. So this is going to be equal to 1 plus 0, 1 plus 2, 1 plus 4, 1 plus 6. That's equal to 1, 3, 5, 7. Okay. But it's easier just to write it as 1 plus H. All right, so I actually have two cosets. Notice that the H and 1 plus H give me all the elements of Z8, so I only have two cosets. So when it's asking for the Cayley table up here, let's go back up and see. When it's asking for the Cayley table, you can just use H and 1 plus H instead of writing the sets here. So if I was going to write, again, if I was going to write the Cayley table, sorry. Of Z8, whoops, sorry, I don't know why it's doing that. Okay. Cayley table of Z8, and let me just write it Z8 mod H. Well, my two elements of Z8 mod H are the cosets, which is H and 1 plus H. And then on the rows, I'd also have H and 1 plus H. Okay, now, next question, how do you add cosets? How do I get, for instance, how would I do H plus H? Okay. Well, the way to think about this is what you do is we're doing sets here, so think about elements in H and elements in H. So I'll say suppose H1 and H2 are both in H. All right. Then I have H1 plus H2 is also an element of H, right? Now this H1 is an element of H. It's a representative from big H. This is a representative from big H. If I take any representative from big H and any representative from big H, I'm going to get an element in big H. Okay, so the way you write this is just H plus H is equal to H. This is how I would do the addition of cosets. Now let's try another case. Suppose I have 1 plus H plus 1 plus H. Right? Now, let's take two elements. Let's take an element from here and an element from here. So let's suppose H1 is an element of 1 plus H, and H2 is an element of 1 plus H. And I want to add those elements together. So I'll take H1 plus H2. Sorry, it's not going down for me. Let's try again. Here we go. Let's take H1 plus H2. All right, now, because H1 is in 1 plus H, I could write H1 is, so I shouldn't write this as H1. I should call this G1 and G2. So let me go back. Because an element of 1 plus H is not in H. So let me just call this G1 is in 1 plus H, and G2 is in 1 plus H. So 2. All right. So how about G1 and G1 plus G2? What coset is that in? Well, because G1 is in 1 plus H, that means there exists, we can write G1 is equal to H1, I'm sorry, I shouldn't put the H1 first. It's equal to 1 plus H1, little h1, for some little h1 in big H. And similarly, G2 is equal to 1 plus little h2 for some little h2 in big H. All right, now we can write the sum of G1 plus G2. G1 plus G2, I can write that as 1 plus H1 plus 1 plus H2. And we can rearrange that. That's equal to, and just do the commutative and associative, you'll get 2 plus H1 plus H2. Right now, notice that 2 is an element of big H. This is also an element of big H. And by the closure of big H, this result is in big H. So what does that mean? The conclusion, every element of 1 plus H plus 1 plus H is in big H. Right? Because I took an arbitrary element in 1 plus H and added it to an arbitrary element in 1 plus H, and I got some element in big H. So we write this as one plus H plus 1 plus H is equal to H. So you can use that in the Cayley table. Now you can, for exercise, you can figure out what is a 1 plus H, and you can also figure out H plus 1 plus H. And use the same method. Now you can also go back to the cosets chapter and see how this worked out. But this is a more, this is a detailed explanation in this particular case. And let's see what else they asked in the problem. Then to do isomorphism, what you do is you take this resulting Cayley table, whatever you get here, and make the replacements necessary. And after you make the replacements, you should get a Cayley table that looks like the Cayley table of this subgroup. You're going to have to write a Cayley table for this multiplicative subgroup generated by I. This is a multiplicative subgroup because it's a subgroup of the group generated by I, and this is a multiplicative group. All right, so make that connection, see what you can do with that.